right here. That's on this red. The tip of that where the wire screws onto it. You measure between there and a ground point on the back plate.
Where's the triangle?
It's right here.
That one. Okay, I see
Yeah.
it. Yeah, it's in that heat
So
sink.
you
there.
put it on the screw,
Okay.
and you put the other one in a ground point,
Okay, there you go.
and we should be reading 89, and we're measuring 120.4.
Wow, that's a lot.
So we're gonna lower our constant here. Let's see if we can get it to come down. Let's see, it's coming down 106, 1098. Now, sometimes when these are way off, there we are at 89.2. I'm gonna leave it there. And since our data point's flashing, we're gonna have to push enter to select it. Okay, and then it's gonna go up to what should be 104 volts. So it goes up to the stop point again. And so we're gonna lower it till we get to 104. Now,
Is this a second point check? The first
Yeah.
one was 89 volts.
it's 2 points on the KV calibration. One is at 89 and one is at 104.
Oh, I see.
Now, what
And is there a ramp between those two or something?
it interpolates it itself.
Interpolates it. Okay, good.
So, there's our constant, and the number itself is not important other than it's what relates to what we should read here, which is 104.
Okay.
So, and what I've encountered when the KVP numbers are this far off is that this power supply board right here is starting to fail, and that may be what we're running into here. It may be that we come back. I'm gonna run the cal twice. We may come back and it may be way off again. I don't know.
Okay. If it is, that means the power supply board's got to be replaced.
More
Are
like-
all parts still available for this machine?
As far as I know, yes.
Okay.
All right. So the next one is MA current cal, and for that, this is the MA where you read the MA. So you're gonna.
You have to get in series between
Yeah.
that.
You have to switch your meter to read MA, and you want DC MA. Okay. And you put one probe in one end of the plug, and one probe in the other,
And then unplug it.
and then separate them.
Yeah. See, what you've done is put the meter in series of that MA line we're at.
Mm-hmm. Okay, and then we're going to shoot. The beam's knife shape. It's very narrow, and it's coming to here, and there's a 1-inch thick plate right here. So all the radiation's between here and here.
Yeah.
So we'll shoot and see what MA we get. That's a warm-up pulse. Where it's 5.66. I'm gonna bump up the constant just a little bit.
What is the MA supposed to be?
6.
6. Okay.
6 MA.
So it's pretty close, actually.
Yeah. And what I usually look for is it varies a little bit. I look for this number to go 5.6, 5.6, 5.6, 5.6.
Oh, I see. Okay.
So we're just below it, just above it, just below it, just below
I got you.
above it. So.
I got you. 5.9 to 6.2. Yeah.
So
6.1.
that's about right there.
Cool.
Okay. So
And the adjustment on the MA, you've still got that opening up, right? So let's see where it is. It's the
plus,
same
you
way.
do plus or minus,
Plus or
and you're going to
minus.
change this value,
Yeah, okay.
and that value it drives the MA driver to select the MA for
The
you.
correct MA. Okay,
Yeah.
gotcha.
All right. So the next one is going to be 10 MA. We don't worry about that because 10 MA is for Ceph, and none of the pc4000s were ever made into Ceph machines. Okay.
You know what a cephalometric machine is, Rev? That's where they actually shoot. What is it exactly, Jerry? The difference.
It's
in pan and
orthodontists
ceph?
use it, and it's a super precise lateral skull, basically.
Yeah.
And,
to get your TMJ measurement
right.
and all that stuff.
They use air posts to position the skull, and a soft tissue shield so they can see the profile of the patient. to do the orthodontic treatment.
Yeah.
So this one
I've
is
seen them go in and peel faces back and change actually the distance here to get to move the bite. Have you seen?
oh yeah,
that?
they do amazing things
Oh
with
my God, it's
with
crazy.
so this is drum travel,
Okay.
and it just you'd know if you had a problem here because you'd be getting errors during exposure. But there's these two switches, one on each side, just to
And I see that's what the travel's about. Here's your
that's
stop.
that's
your
the
cam
travel
there, yeah.
travel limit.
Okay, I got you.
And this is an elliptical tomograph. As this rotates around, the center also translates back and forth.
Okay.
So-
It looks like this is weighting that down right into the.
And that's with the one I had to move
Do we
over
want
to
to move
Texas City.
this back?
We do. We're probably going to put it
Okay.
back over here
Because
somewhere.
I saw that getting against the belt, and I see that's already some kind of a problem.
All right. So
Okay.
hand speed left. And what we do here is we're going to get our stopwatch out on our phone.
Okay, I'll take care of that.
I always return this back to this position so I don't blow fuses on my meter.
Yeah.
What should the travel time be? What are you looking for?
12 seconds.
Okay.
12.0 seconds. And there's going to be a warm-up pulse, and you start your time when the machine starts to
Starts in
rotate.
motion?
Yeah,
Okay.
it starts to rotate. I'm going to run mine too, just for a comparison. Okay, so
Oh gosh.
and we're a little fast. We're about 11 seconds. The service menu tells you what to do. Press enter to reset the rotation.
Okay.
And our cal value is 103, and in order to increase the time we need to make the rotation slower, so we're going to reduce our cal value.
To like 100 or?
It was 103. I'm going down to 84,
Wow. Okay.
and we'll see if that was enough or too much here. This time there won't be a warm-up pulse, so or there was a warm-up pulse. Usually there's not.
I got 11.
I got 11.46.
Yeah. 11.3. It depends on when we stop it, I guess. So bringing it down that much increased it a bit, right?
Right.
About.
Got us closer, but not close enough. So I'm going to lower it some more.
Can it go negative?
No.
Okay.
All right, 12.24 that time, so I'm gonna raise it back up again. $73. I'm gonna go to 70. I'm gonna go to 80.
I got 1175.
1177. Yeah, so we're close. So go back down to about 76 on the constant here and see what that does for us.
$12.05.
12.1, so we're going to leave it right there for right now. It needs to be plus or minus 0.5 seconds.
Yeah,
So,
I got 12.05. So
Yeah, so you're good. I think, and there'll be a more accurate way when we do the calibration to determine what the exposure time is.
okay.
So that's exposure time. It has a pan speed left, pan speed right, TMJ speed left, TMJ speed right, and I just do the pan speed in the direction that they use it.
Don't worry about the TMJ speed, right?
Yeah, don't worry about that. Exposure count, if you're interested, is 6,088. Okay, so there's a beam alignment thing right here, and we're gonna go to the manual beam alignment on the software.
That's the first step, right? Is to make sure your beam is aligned correctly.
Right.
Is this almost the same procedure as if you were installing it? It's exactly
Yes.
what you'd go through.
Yes,
Okay.
it is precisely. And like I said earlier, we're probably going to go through the cal again to check those. We check those kV settings.
Yeah.
But here's our maintenance menu right here. Tools, maintenance is what I was trying to describe to you the other day.
Uh-huh.
And what we want is mechanical alignment. And that's going to pull up this. And what we're looking for is ideally 3 green numbers, which is the alignment left and right here, the alignment left and right at the top, and the alignment up and down. But practically, we want to see space on this side of where the beam hits and space on this side as well. So we want the beam to be somewhere between the 2 margins of the
Within
sensor.
that slot, right?
Yeah.
Okay.
This represents the,
The slot,
the
yeah.
sensor space.
Mhm.
And when we shoot, it's going to show us where the beam is hitting. So,
Is that a software adjustment or a mechanical adjustment?
mechanical. So that's dead on.
Yeah.
That's dead nuts right there.
That's beautiful.
It gets no better. Alright, so we're aligned. That means nobody's bumped the tube head
Oh, good.
to move it out of alignment or anything like that. So, if you did need to move that, there's 2 ways to adjust it. If you take off this collar right here with these billet screws, there's some Allen screws that hold this yoke in place.
That's a 2-piece collar?
Yeah,
Yeah, okay, it
it's
just
a
comes
2-piece
in
collar
2
that
okay.
comes off, and you loosen some of those, and you can bump the tube. It's not going to take a lot of movement to get it aligned. The finer adjustment is going to be to take the cover off of the sensor, and then there's screws and adjustments on the sensor mount to move the sensor slightly.
Slotted?
Yeah. It's also important not to get the beam skewed. In other words, you want the center of the beam to be right down the middle of the arm.
Yeah.
You don't want it to be off this way and make your sensor come over to meet it.
Yeah. Almost
Are
like
you
a
gonna-
grid
are
alignment
you gonna
thing,
get
too, yeah.
Are you going to get a really asymmetrical pan? Screwy?
You want to strike it at a right angle, as much at a right angle as possible.
Right,
Yeah.
dead center.
Okay.
They used to say when they had film drums, they said took the film drum off and you put a screen on the film drum shaft to make sure that you're hitting dead center on the.
Well, now, Jerry, it seems like if you're adjusting the tube, you're more likely to get it skewed than if you're adjusting the sensor.
Not necessarily. If the sensor was aligned properly at installation, it's unlikely that they move the sensor during use.
Okay.
It's
So,
more
so
like,
if it's aligned properly.
it's more likely that somebody bumps into this and
I
gets
see.
it
You
skewed.
just need to put it back where it's
Just to
supposed
put
to
it
be.
back to
I got
just
you,
center.
I got you.
Yeah.
Okay.
All right,
Okay,
so
that
that's,
makes sense.
that's
Yeah.
beam alignment. And the last one is pin test. We're not going to do that right now. We can do that later. And that's just an exposure where we use a pin test block to measure the symmetry of the scan.
Okay.
All right, and that's all of the calibration. Let's look at the KVP again and see.
So to recap, what we've actually done, number one, the KV adjustment to get it accurate.
Was way off, yeah.
Yeah, and there's two adjustments for that, the 89 and the 104, correct?
Right.
And then the next step is to check the MA.